Director of Air Warfare on the CNO staff. He's responsible for the development, programming, and budgeting of all U.S. naval aviation warfighting requirements, resourcing, and manpower. And I'm particularly excited to have the Admiral with us today because he's pioneering the Navy's efforts to develop a concept known as Naval Integrated Fire Control Counter-Air, or NIFCA. The bottom line is the Navy's proactively transitioning from an industrial approach to warfare to the information age. And that's obviously where I believe we all ought to be heading. So just as we've seen in the civilian sector, increasingly capable networks and computing capabilities are turning information into the dominant factor in modern military operations, a phenomena that is more and more increasingly being referred to as the combat cloud. So NIFCA is aligned in this vein, harnessing information as a central asset to secure desired effects. It's no longer sufficient to focus on traditional aspects of power projection, but rather what will be key as we move into the future, and I believe the underlying basis of the third offset that you hear many people talking about, is going to be the ubiquitous and seamless sharing of information. With that bit of an introduction, let me turn it over to the Admiral so we can all hear what his vision is and what he has to say. So Admiral, the floor is yours, and thanks for being here.
Thank you.
Appreciate that. It's a wonderful introduction. It's exactly where we want to go. I'm very humbled and honored to be here. I see a lot of friends in the room. More importantly, I see a lot of fighter guys in the room, which means it's going to be a ready room atmosphere. Back row shooting at the front row lecturer, for my Top Gun technique. How do you hold the pointer with two hands? It is great to be here today, and the General gave an introduction that is exactly where we want to go. So I'm the Director of Air Warfare. I'm not going to talk to you today, at least outright with a brief on, here's why I need an F-35, or here's why I need this many Superhornets. What I hope to have a dialogue with you today is as we approach the 21st century warfighting, so General talked about information warfare and why we have to go this direction. I want to talk to you about defining the problem. So Einstein, great quote, 1 hour to save the world, 59 minutes defining the problem, 1 minute for the solution. So we're going to spend 59 minutes, in fact the General's giving me about 59 minutes, but I'm going to use less than that in slides and to talk to you about defining the problem. Many of you who have heard John Richardson speak will see some familiarity with the material here. What my boss is interested in, I'm fascinated in it. But actually, what he does is starts to capture where we all need to go. So I'm not going to tell you today at the Air Force Association why naval aviation is the way to go, Navy Admiral. I'm in the company of friends because now we are pioneering Navy integrated fire control, but really all of us are trying to get to integrated fire control and the information necessary to do it. So my brief today is going to talk about a couple of forces that face the United States, and then why the United States Navy is looking at those forces, and what we have to do about it. Again, defining the problem for you, so we can think about an intellectual approach to what warfighting in the future looks like. So next slide, please. It's a contest. 1984, I went on deployment on the USS Carl Vinson in an F-14A and VF-51. I was escorting Bears. The Bear pilots were trying to scrape me off on the mast of the USS Carl Vinson. They were trying to crash us into each other. I was on the ship doing an unrep with an unrep ship, and a Russian AGI went right down the middle of the ship, and we were 160 feet apart, and the captains had to do that. In my experience as a captain of Nimitz, I know what that would be like if somebody is trying to hit you. We had a contest at sea back then. 1989, the wall came down, no contest. We've been predominant and superior at sea ever since, although we haven't fought at sea. The United States Navy hasn't fought at sea since 1944. That's a problem. Next slide. So we have a contest. We have competitors. We kind of understand who the competitors are, and I'll list a couple of nations for you and what the Secretary of Defense calls 4 nations and a characteristic or a condition. But really, hit the next slide. It's about the character of the fight going ahead. What kind of character of an environment are we in? How do you characterize the environment? Why is it important to have a Department of Defense structured the way we are? Then, of course, in my world, working for the CNO, why is it important to have a Navy structured as it is going forward? it gets to the idea of how many airplanes we need, how many ships, what are those things we need to do. But it is more complex than that, as generally that people said. Next slide. So global maritime traffic, pretty common. You see this a lot. Since 1992, ships between 1992 and 2012 have increased fourfold. 300% increase in shipping traffic in the Indian Ocean, arguably the most busy and sort of aggressive shipping lanes in the world. Several choke points there. But consider this for a second. While we had smaller ships in 1992, and we had slower speeds, we now have higher speed of ships, and the ships are gigantic. The number of TEUs, the Connex boxes that are being shipped now all over the world, continues to increase at an unbelievable rate. It is widely accepted that 90% of our goods travel by sea, but it is true that 80% of our merchandise travels by sea, and that trade is only going up. Some of the traditional ones you can see in dark yellow there, you can also see the opportunity. Look at the eastern coast of Brazil and the western coast of Africa, the Gulf of Guinea. If Nigeria could figure out how to get past some of the economic challenges in the Gulf of Guinea, you could see that trade starting to go into that developing environment. 1.8 billion people in developing countries are going to enter the consuming humanity, enter the consumption force, as it were, between now and 2025. 1.8 billion people. We'll talk about technology in a little bit, but most of those people will have 2 or 3 devices. They're going to be connecting to the internet. So maritime trade is driving what we are doing with the United States Navy and what we're focused on, and that is our first force, or flow, or current, that characterize the environment. Next slide. In the undersea domain, our technology is allowing us to reach deeper and deeper and to get into places that we heretofore have not been able to get to for exploration purposes. We've been able to kind of go down, take a look, and see what's there. But fully 40% of our polymetallic sulfides, copper, zinc, gold, and silver, reside on these tectonic plates, and fully 40% of those are within 200 miles of the coastline. 200 miles sounds familiar to you, that's EEZ. Now right now we have technology barriers, legal barriers, other barriers in place, and we can't quite get down and get those, but that's where the opportunity lies. And so these areas that you see in the green dots have more opportunity for trade and for preservation of the capability to be able to allow countries inside of their EEZs to go down and get those polymetallic sulfides. Next slide. Undersea cables. 99% of the data, the voice and technical data in the world goes on undersea cables. Only 95% of the United States data and voice goes over undersea cables. 95%. Underpinning the trade, underpinning the information domain that we have, the flow of that information is in these undersea cables. I think you read in the open press what some of our competitors are doing with those undersea cables, the postulation of what they're doing down there. So it is in the maritime, on the seabed, that we have these undersea cables, and it requires us to think about how do we protect them. The information system that goes across these cables is also underpinned by what's in space, the high terrain. Space is asymmetric. You do a lot of things up there because of the way you can move those around the world. There are right now about 18,000 man-made objects in space. You kind of see them there. And there's about 1,305 operating satellites currently. We pay a lot of attention to satellites, especially with our peer competitors that try to get information about where our forces are. We also worry about our ability to use space in a future competition against somebody else. How do we replicate what is currently being done in space? You'd be surprised, as I was, potentially, that only 7% of our information flow goes into space. So 95% United States voice and data across undersea cables, only about 7% gets across space. So if we did have those cables cut and we wanted to rely on space, we'd have to think about how much data can go across the space domain. But obviously, now we've described undersea, from the littoral, all the way to the blue water, all the way to space, as our domain. When our traditional domains of sea, air, undersea, for warfighting, submarines, airplanes, ships, we think of those domains. We have to continually think now more across domain effects. What you do in one domain is going to affect what you do in the other domain. What I do with my future air wing is connected to what Pete Fanter does with his future ships. It's coupled with what Chas Richard does with his submarines. It's coupled with what A5R and A8 are doing with Air Force systems. Our long-range bomber potential with short-range maritime systems. How do we assure winning in that environment? Next slide. So our information system was the second force that we had. This is patents. Sorry about the, kind of see the titles on the margin there. But this is patents granted to the United States. Navy applied for patents in 2015, 393 patents. That's the most since 1973. The Navy's chase of technology improvement and innovation has accelerated. Next slide. When you throw private manufacturing on top, you all can read the economic press about where we are in private manufacturing, but the innovation that's going into manufacturing, total output per worker, is going up because of what we can do with machines. This starts to foreshadow man-machine teaming that we'll talk about on one of the last slides that we're after. But the productivity per person has gone way up recently because of what we can do with machines. And I won't talk about the economic stagnation of the worker in the United States. That's all political, very real. But what you're seeing is, for less money, you're getting a greater output because we're thinking about what to do with machines. What happens with 3D additive manufacturing that takes processes that used to take this much time and shrinks it down to something microscopic of that. And in the numbers, what you do with that technology to be able to reduce costs. Next slide. Servers and internet hosts. In 1993, first server gets shipped. In the first quarter of 2015 alone, we shipped 2.7 million servers. In 1995, there were 63,000 internet hosts. Top of that curve, 903 million. So the data flows between people, the connections to the internet, and the machines coming on is so much faster. This is what creates that second force in the information war. We need to stay ahead of that force. War gets democratized. A single person with a server and internet host can start to change the dynamic of the dialogue across national borders. We haven't seen that before. You're seeing that now. Well, of course, Admiral, you've seen that for, guys got on the internet, bad people like ISIL are on there. But are we reacting to this force? Do we know how to react to this? Can we be faster than our adversary? And taking what traditionally we buy in naval aviation, airplanes, and networks that I have, and remaining ahead of this force, the information force, the speediness of trade, the speediness of innovation outside of cumbersome government processes like we have to use to build things. This is the force that's pushing us. Next slide. So there's a piece of this technology that is adoption of the technology. It took 46 years for 25% of the American population to adopt electricity. Now think about where that is. So 1873, Wild West, just after the Civil War, the country is putting itself back together. There are urban centers of innovation, manufacturing, ideas, and then there's the Wild West. So as I look at this, well, gosh, 25%, didn't they know that electricity kind of makes your life better? You could turn on the lights and, read at night or something like that. No, they had a culture that said, this is going to mess with our lifestyle. We don't want that newfangled thing. I don't want that telephone in my house. That means I have to talk to somebody. That means I can't walk down the 1.5 mile road to old Yank's house and go chat with him, for an hour and a half and then walk back, and that's my day's activity. Look all the way out here, starting with a PC in 1970. Wow, what's this computer thing? And then what can I do with it? And now I can walk around with it. And the smartphone, I can tell on the map, and I can tell what to eat, and I can connect with people who are like me, and I connect with people, I have an idea, hey, all these people, and then all the stuff that's happening here. So 4 years for 25% of the American public to adopt the smartphone, 3 years for 25% to go to Facebook. Culture. Bernolson and McAfee talk about in a book called The Second Machine Age, that we are in second machine age. First one is steam. Steam helped us to overcome muscle power. Didn't have to pull using 20 mule teams and 55 people to create a steam engine. Second machine age now is where information is allowing us to overcome mental limitations. And you can see this culture down over here. Are we postured in the United States Navy to stay ahead of this? Next slide. I took this out of The Economist last week. Many of you might have seen this. This is a depiction of Moore's Law with transistors. So Moore's Law, 1965, it's not a law really. Gordon Moore said, hey, in order to stay ahead of the competition, I got to double the things that we're doing, double the processing speed of our transistors, double the number of transistors per chip. And it's pretty much true, because we've made it come true. So here in the United States, we've been very good, and across many of our technologically advanced nations, we've been very good at doing that. But interestingly enough, if you put the number of transitions or transistors on a chip, they obviously get smaller and smaller and smaller and smaller. And you start to reach a theoretical limit about the size of those transistors. I don't know anything about transistors. I looked at a picture. There's a source and a drain, and there's a gate in the middle of them. And they switch on and off. And all those ones and zeros make those things happen. And make the transistor combined with other transistors in the computer to make it do its thing. So if you got a gate that sits on top of a block of silicone and it gets to its limit, then let's raise the gate on top, and you can put the gate now on 3 sides of the medium, and you get that flow coming through there. Well, it turns out that when you get smaller and smaller, so 40 nanometers between these things, and then down to 20, 15, 10, 5. Now there's 5 nanometers between the source and the drain and the mechanics in the transistor. When you get that close, there's leakage of these electrons that flow through there. And so you can't quite switch them on and off. So the clock speed to go 0 to 1, 0 to 1 kind of gets a little bit dribbly because you've got a little bit of flow in there that you can't quite turn off. So they're trying to figure out, if they're going to go that small, how do I just kind of have the, not quite off and not quite on and still keep it fast? Additionally, we've kind of gotten to the limit there of the heat, what's the word? Dissipation, thank you very much. Fire department. Heat dissipation rules, neat, by the way. You'd always need help from the backseat. We flew together. So heat dissipation in the silicon, so maybe we need a different material. We can see here that while Moore's Law continues, we might be reaching the theoretical limit of the way we construct the transistors that we know how to construct. So you see that dissipating the heat and the clock speed is starting to level out, which means we have to think about how to do something different with that. We can't just depend on the processing power of these things that Intel puts on TV. If we're going to get ever and ever more advanced, we figure out the theoretical limits of things that we used to think were continuing to double. Back in 1965, Gordon Moore thought that, maybe this won't be true, but I think for the next 10 years or so, I think this law is going to be true. That would be 1975, so look where we are. We might have reached the theoretical limit of the current transistor design, and now we're looking for different ways to put computing power in different forms. Google's talking about doing a quantum mechanics computer that apparently, and I know nothing about this, can do calculations in a moment, which it takes our current supercomputers millions of years to do. That to me is inconceivable. I can't conceive how that would happen. But we can see that you have to do something different if you're going to stay ahead of this. And if Google's thinking about it, and maybe Alibaba is doing that kind of stuff, and other companies that are in different places and our competitors, and we know that competitors in different countries are very good at this, what are they doing that we might not be thinking about? This is a force. This is something that's pushing our ability to advance our weapon systems and ability to remain competitive. So I would characterize those three forces: the maritime trade, information flows, or information flows good, and then the rate of technology change or innovation as three currents or flows. So let's put them in a river. Me and you are all in a boat in that river. This is the paddle. This is how we maybe go down the river. You could argue that when the budget's going up, big giant paddle. Paddle a lot. Go over there, I can go over here. Maybe my paddle's getting a little bit smaller. Very familiar to everybody in here. DoD budget, Navy budget, Air Force budget, everybody's budget. Going flat. GDP across the world right now, through 2016, is averaging about 3%. Western defense budgets are flat. While over in Asia, they're going up 24%. Our competitors are investing. Is their investment effective? Is our investment effective? Our challenge in the United States Navy and in the Department of Defense is to figure out how to make that paddle as effective as possible when we're working against those three flows. Next slide. So let's talk about our competitors. Next slide. They're pretty obvious to you. So the two top ones, China and Russia. Secretary of Defense talks about this. You can just go ahead and hit it. There's North Korea and Iran, and then ISIS, or the phenomenon that is worldwide terrorism. The tragic report from this morning is another example. This is not going to go away. How do we protect our borders from people who want to do this? The technology, information flow, and the democratization of warfare with the number of hosts that are out there allows people in the black cloud there to have effects like they had this morning. In Belgium, we have to figure out how to combat that. You can't build a wall. And I don't mean to refer to anybody who's on a podium. You just can't build a fortress around our countries. It doesn't work. They're going to get in. We see that in computer virus stuff all the time. No matter how big you build your fortress around your computer program, they're going to get in. You got to figure out how to address that. Most of us understand that this black cloud is not a huge threat, a strategic threat to our country, to the survival of our country, a vital threat. It's not, but we have to look at the effect. As I go up from the bottom, Iran wants to be hegemonic in the Arabian Gulf. They want to extend the Shia Crescent, as they've shown, all the way across. They have proxy wars over in Yemen. They want to help Syria remain the way it is. They want to partner with Russia, because what that gives them as they move through Iraq is a greater Shia presence across the eastern side of the Gulf. They want to own the Middle East. They have for a long time. North Korea, I think the man's insane. But he definitely doesn't have the same rational thought that we do. From my perspective, he's irrational. We have to figure that guy out, and he's getting supported by China. That could be an existential threat to our country if he puts nuclear weapons on top of a ballistic missile that can reach this country. And I think we treat it that way, at least that particular threat. North Korea, generally regional. But if he can reach the United States, he becomes strategic, and so we have to think about that. A resurgent Russia with an adventurous Putin. They're kind of backed into a corner. Their economy is in horrible shape, but they've got pretty good warfighting equipment. And it's very, very interesting to read what he's doing in Syria. Going in, going out. What he did in Crimea and Ukraine. They have very good equipment. We have to respect that equipment. They're at sea with their ballistic missile and attack submarines more than they have been since the Cold War. We're addressing that threat in the Navy. He's coming to sea more. The Bears have flown against terrorist strike groups more than they have since the mid-'80s. both Air Force and Navy and coalition countries are intercepting Bear aircraft more than we have since the mid-80s. A resurgent Russia. China's economy increased double-digit inflation. They are the biggest shipbuilder in the world. They've exceeded the United States in shipbuilding capacity. They're building warships, they're building container ships. I think we still hold the high ground, air and space, and I think we will for a long time. But they definitely have, I think, the weight of effort in not only the capability of the ships they're fielding, but also the capacity. And they're learning from us. So for me, in the United States Navy, as I look at all of our capabilities, especially air, but also combined with the rest of the domains, I would say that China is our pacing competitor. And that's the guy who, if we're running the race, you can hear his cleats on the cinder track behind you. Next slide. Next slide. So we talked about sea trade. 90% of the world's oil passes through a choke point. That yellow dot is the range of the Charlie 802 missile. That's 75 miles or so. Hit it again. That red dot is unclassified range, right about 900 miles, the DF-21. You can see how a competitor could control flow of trade. Next slide. Sir Walter Raleigh, back in the late 17th century, said, "He who controls the sea controls the trade. He who controls the world's trade controls the world's riches, and consequently the world." I would tell you the why of the United States Navy is to make sure that the trade can stay in the current world order that it is, a rules-based world order, one in which we certify, allow, support, deploy to support this world order of trade. The United States-based world order, the Western-based world order, keeps us in the game as competitors. That we can't allow a competitor who wants to own either a region or to change the world order to exert control over choke points like that and start to bend trade to their benefit. We have to keep it open. Next slide. So the mission of the United States Navy, a bunch of words here, highlight a couple, hit it. We've got to protect America, preserve America's strategic influence in key areas. Defense of the homeland is number one on our strategic hit parade. That's what the CNO talks about. You'll see our investments, top investments in the United States Navy go to that. You see budgets reflect defending the homeland. We talked about seafloor, deposits, cables, access, all the way to space, getting into the littorals. You can see it in the South China Sea with how complicated that is with islands and archipelagos and deep water and all the claims to that. And then all the way up into space, talking about the high terrain. We have to partner with our allies who are supportive of the current world order. Not only in capacity, but also capability. Next slide. And if we have to, and this is the part that gets the hardest for budgeting for me, is we have to have a big enough stick where if deterrence doesn't fail, I have to have a credible enough force. We have to have a credible enough force to be able to enforce the things I just highlighted. Next slide. Next slide. So the CNO has created a campaign design for maritime superiority. And he talks about this. And it's a placemat that we can use to go forward in this competition. So how do you make the United States Navy more effective in the future fight? Characterize what we just talked about. First of all, it's founded on a force that has a level of integrity that we adhere to our values. We have an accountability that says we're going to set goals, we're going to go after those goals. We have an initiative that says even the youngest petty officer has a good idea and is valued for his or her good idea. You see articles about innovation, how we bring innovation to the fore. Where does it come from? It doesn't come from me. Definitely not in the Pentagon, the system that I got to work in. And I'm old. I was back in electricity where it took 46 years to adopt it. Now I got kids way over there on the right-hand side. Toughness. We will not give up the ship. 4 lines of operation listed here. Strengthen our Navy team talks about how we make ourselves better. And we're doing it at all levels. Sailor 2025, different way to train. The blue line of effort, enhanced power at and from the sea. What equipment we're putting on our ships. How do we put our ships together? How do we connect our ships with our submarines, with our airplanes, with our weapons? Different. And then high velocity learning is how do we learn differently? How are we a learning organization going forward? Partnerships. By the way, the United States Marine Corps is in the blue line of operation. They are naval with us. They're not the #1 partner, as some people have tried to say. They're embedded in the blue line of operation. So everything I do in naval aviation, I connect with General John Davis, Deputy Commandant for Aviation. CNO is absolutely tied to the hip of the Commandant. I'm going forward. We're a naval force. We're a naval expeditionary force. Air service, subsurface, at sea, in the littorals, amphibious to deep water. But expanding our network of partners is not only allies, but industry. This. Academia. Where do the good ideas come from? How can we rapidly put those ideas into play? And then that supports the mission that I listed out for you. Next slide. Next slide. Only build it one at a time. Next slide. Okay, so if you take an exponential curve, so CNO is a nuke. I was for about a year and a half. I got to learn nuke, and then they let me drive a nuclear-powered warship. Awesome. So what I remember from nuke school is that's an exponential curve. Great. But if you use that exponential curve there and you say this is the theoretical limit of technology, whatever technology is, just a simple example of your theoretical limit. Okay, so we looked at Moore's Law. It was kind of a line like that, but actually the application of Moore's Law technology was exponential. I go to the next slide, or hit it next. Okay, and if you assume kind of that's where we are. So back here, early on, 80s, 90s or so, when the computer came out, hey, we're kind of ahead of technology. The Defense Department was kind of leading innovative stuff. Now the commercial world's kind of taken over. But we sort of, it's not flat, but it's kind of, we're doing pretty well at staying after technology. Again, for illustration's sake. Next slide. So right about now, next slide. So where's the bad guy? Well below us in the past, through lots of different ways. So let's just say the competitors, there are lots of different ways they're starting to approach us. I believe right now we can take on any competitor in the world if it was a contest for superiority. Whether it's tactical, operational, strategic. But again, cinder track, cleats on the cinder track, they're right at our shoulder. If we don't keep our speed up, if we don't continue to chase the theoretical limit, we're going to be passed. Sometime in the future, if we don't change what we're doing, Department of Defense-wide, the things the General talked about in the intro, we're going to be passed by one of those competitors. Next slide. So how do you chase the theoretical limit if you're blue? Well, you can do a step jump up there, some huge innovation that comes true, that there's zillions of examples. You jump up to the limit of technology right now. And we instantly are able to put that technology in place. The thing that's holding us back is the bureaucracy surrounding substantiation of technology. It's like we're running a race and we got one of those parachutes that you use on the practice field to make you stronger for the race later on. Well, the problem is when we go out to compete, we keep the parachute on. JSIDS, UD 5000, get a parachute on it. You got to cut the parachute to be able to get up there and then to bend it around the theoretical limit. Now another piece of thinking, I didn't really build the slide this way, but thinking about it, so if that's the theoretical limit of technology and we're able to bend it around there, what happens if you can use combinatorial stuff? You can use things like man-machine teaming to actually take that curve and bend it over past the technological theoretical limit. And that's what we're breaking into now. That's the third offset piece. How do you get that way on the other side of technological theoretical limit? Next slide. So here's where my brain is right now. Looking forward to buying naval aviation that will fight in the future. We have to be willing to fail. You've seen a lot of sparklers of innovation here in DoD. They're all over the press. we're grabbing a hold of things and taking them and putting them in place. Dr. Roper's got a SCO, the Air Force has got an RCO, and the Chief of Naval Operations instituted an MACO, a Maritime Advanced Capabilities Office, inside the OPNAV staff. Quite frankly, bureaucratically, we're trying to figure out a way to put that in place. To put the rule set in place that allows us to go faster than the dragging parachute. I think we have to be willing to fail. Back to that technology adoption slide with the bar charts and electricity all the way out to the left and computers to the right. You have to have adopters, early adopters that will take your stuff and go play with it. I want the ability to play with stuff. Give it to the sailors, give it to the officers, stick it on our ships, get it out there and see what happens. The hard part is arguing about what the end state is of those things. Well, I don't know yet, in some cases. I just want to try this thing, see if we can bend the curve. You got to know and manage the risk. We need to invest our money in projects that will extend our innovation, extend the limits of technology, and maybe fail. A lot of my programs right now are so far along and mature in their instantiations that if I tried to cancel them, the fear about sunk cost comes to the fore. How much money you've already put into this. I know, but I'm behind. I got to figure out how to change the tires on the car while we're driving. How do you do that? How do I take money currently going into programs and shifting it over to something that can bring the technology? That's our challenge inside the Pentagon. That's my challenge. I went to a systems approach. Integration interoperability. We actually only started after this integration interoperability. I was at a brief in 2010 where about 150 NAVAIR and OPNAV folks met with the CNO and the vice chief and talked about, hey, you know, when we field systems, we're kind of stovepiped. How do we get them together? Well, 6 years on, we're focusing on it. We haven't gotten to the point where we can really integrate and innovate. We've got Navy integrated fire control. We're breaking into the systems to be able to do that. We're just getting to the point where we're actually starting programs from the position that they have to integrate and interoperate. We're talking to our Air Force partners through organizations like the Joint Air Dominance Organization, JADO, and saying, hey, how do we go forward from that perspective? And not, this is my thing over here, this is your thing over here. They go like that. Hey, how do we connect? This Navy integrated fire control nasty, this NIFCA thing you got. Is there a JIFCA? Is the Air Force connected there? Not yet, but we're talking about how to do that. There's some mechanics that you have to do to put that together. And that's what we're at. You've got to do that. I'm in a Tomcat. I have an AUG-9 radar. I have an AIM-9 missile. I've got an AIM-7. I've got a Phoenix. I've got a target. And I've got my radar intercept officer, me. Independent. I get a radar contact, maybe the E2 is talking in my ear, and I go attack that guy. Independent kill chain. Interconnected. In that Tomcat in 1998, Joint Tactical Information Distribution System, JTIDS, Link 16. I'm getting my wingman's contacts in my cockpit in an F-14D. Now we've got all of our airplanes on Link 16, or most of them, and I'm sharing pictures, so we're interconnected. I federate a system, I can put them next to each other, and the federated system works great, but I can take the federation away and it still works. Fully integrated means now that system has to operate just like this. If I pull it apart, I have to put it back together in a different integrated manner. And then interdependent means I can't operate unless it's that way. We want interdependent systems. The problem is your Achilles heel of an interdependent system is you maybe have single points of failure. So you need to be able to move back and forth. I need to have an individual aircrew, airplane, weapon, sensor, target pairing, and I need to be able to share it across a network. I have a kill chain that goes across and puts together all of the things necessary to apply an effect to a target. How do I do a kill web? So I can match shooter A with sensor D with weapon P with target X and do that quickly. Integrated fire control. so that as you start, everybody has the same picture. Good guys, bad guys, unknowns, neutrals. And minimize the unknowns. As we go forward with all of our high-end warfighting capability, our ability to do it in clear air is running out of it. I can't. We go out to Fallon and train. I don't take full 5th generation capability to Fallon and do it in the clear air. I have to do it in a simulator. We have some very nice virtual constructive environments. The Air Force has been running distributed mission operations now for a long time. We're starting to get into where you can connect a live airplane into a virtual environment. So picture person in the simulator in a complex in Fallon, in Nellis, in Key West. It's in a representative simulator, very good, testing all his stuff out. Might not be exactly like the cockpit to reduce costs. He looks up in his dome and he sees his wingman section out over there. We're used to that in simulators, we see that all the time. But what if that wingman section is actually a section on the range of F-35s or Super Hornets, and he can see exactly what they're doing, including when that live airplane hits the chaff button or the flare button, actually, and he sees the flares come out, or that airplane live shoots a constructive missile live, but the guy or girl in the simulator sees the missile come off. And more importantly, the live airplane aviator looks down through a joint helmet mounted cueing system and sees the simulator flying alongside of them, that far away. So when the simulator action happens, missiles, brakes, things like that, maneuvering, down in that tub, not really in the air with him, you can see that. That's the LV. And then the C is the constructive. We also have LC. So you have a live airplane with constructive. Right now in the virtual mission training system down in Pensacola, we train our TAC Air backseaters in that system. I went down over a year ago to Pensacola and watched a section of students go out in 2 T-45s. Student air flight officers going to be TAC Air folks in supers and growlers in the backseat. And they were executing, talking, doing tactics better than I did in Top Gun as a senior junior officer. And we're training those guys at that level. In front of them is, they're attacking 2 bad guys and they're doing tactics against them and shooting missiles at them. There's nothing in front of them. Doing it all on the constructed scenario on the display. Then they turn inbound to Pensacola Beach and they attack a ground target on the beach. Obviously, not there. Displayed again on their system. T-45 has no combat system in it. We just put the stuff onto a screen. We're looking right now at doing that for the TAC Air pilots in the T-45, so that when the pilot is looking down, trying to do his tactics and fly the airplane, he's getting introduced to those constructive scenarios. Not only getting introduced, reduces costs. If I put that stuff in a Super Hornet, if I put that stuff in a Joint Strike Fighter, I can send blue forces out and take a section of folks out over the water or into a range. I don't have to supply them with 4 bandits and surface-to-air threats and jamming. It's all constructed. So running out of space, I can do it this way with an open architecture piece, break open the things that many of you provide to me, or to Naval Aviation, to Air Force, and put in things like that in open architecture systems. Down at ITSEC for the cross-domain piece. We're down at the ITSEC training symposium in Orlando this last December. We've been trying to put together a network down there, and the hurdle to put together the network is what standards are you going to use to connect everything together. We couldn't come to a closure. Over a year of trying to get to closure, and finally, TST through their strong leadership down there said, hey, we're just going to put a network together. If you guys want to come play, you can play. 30 companies brought their system, and they figured out the cross-domain solution. And it was all with company IRAD money. And I was jumping up and down like a little kid cheering. Because we go in the Pentagon, go into a meeting with SESs and admirals, we can't figure out how to write down the standard. And the Bubbas out there said, hey, let's just go figure this out. And look what happens. And it's going to get bigger and bigger. It's called Operation Blended Warrior. It's going to happen in the next ITSEC, and it's going to continue to do that as we bring in these ideas about how to take currently fielded systems, which were built on proprietary structure. How do we open those up? Do we get them all the way open, or do we put a cross-domain solution? Next slide. So I have 3 5th-generation questions. They're listed up there. Things I think about all the time. We talked about a kill web already. How do I take a normal kill chain turn into a kill web? You know that tool that talked about it. 5th-generation warfare is informationized. Informationized warfare. The F-35 as a single platform is bringing us that capability in a single platform to be a node of information. Now we're trying to figure out how do we share that information. The ability of that computer system, airborne, to suck in all this information and then distribute it out is something that we haven't quite cracked. And you know what? We didn't design the airplane that way. We designed it to go in as a division, go into heavily defended territory. Nobody else can go there. They go in and do the mission very, very effectively, and they come back out. That was great thinking. It's very, very good thinking. But now, in order to bend that technology curve, we have to figure out how to get the information off of that airplane while he's inside of that A2AD environment, where before, no, you can't transmit anything, they'll detect you. But I need all that stuff. So we have to figure that kind of thing out. High tempo warfare, what that means, I don't know. But I'll show you a picture in a second here and give you a vernacular. I have been advocating for, as have my champion partners in the Pentagon, for a number of platforms. I need this many F-18s, I need this many E-2Ds, I need this many Growlers, and then I develop, I already know why, but then I go show John and people like that, okay, here's why I need that many. I need to talk about is network capabilities. How do we maybe level out the platforms that we have and now make them better, again, bending that curve? How do I do that? Again, changing the wheels while we're driving. We've got to integrate air and sea power. Man-machine teaming, very small, right down there. That funny stealth movie, you know, with Jamie Foxx and the bad guy stealth thing that tries to go kill everybody. That's the future. The unmanned system coming off the carrier, the instantiation that I think about is 3 wingmen in an F-35, a single pilot. Combat spread now is 25 miles apart in 5th generation tactics. Imagine a single aviator owning a 100-mile front of air dominance or air superiority. Because that pilot is talking to the extended unmanned systems. Triton and P-8 are going to be connected together. The man-machine teaming piece. So we just had the dream, the AlphaGo thing beat Lisa Dahl at Go 4-1. You remember 1997, Gary Kasparov and Deep Blue, 8 years to build that computer, 1.4 tons of machine. AlphaGo and a system like Watson now fits into pizza boxes. AlphaGo beat Lee Sedol because it used neural networks, learning machines. I think most of you read the point where you got man capability here in this second machine age to about here. You can put machine capability to about here. And that AlphaGo program, by the way, learned from previous human games. And then did some probabilistic value-based priorities and how it got to an answer that Lee couldn't go after. But when you take the man-machine team, you get another step up, again, a way to curve that technology. Third offset is about man-machine team. Where do you put the person in the loop? Next slide. So, Colonel John Boyd, thank you very much, F-16, irascible, P&E kind of guy, comes up in the 1970s with OODA loop. Cliche. Say OODA loop all the time. Actually, when I think about this, it's still extraordinarily valuable. Extraordinarily valuable. So I want you to get rid of the cliche idea of the OODA loop. As I think about trying to put together this stuff, maybe machines do the observe orient for us. And that goes to machine time, milliseconds. Here's the picture. Now I sit there as a human and I go decide what to do. So maybe this OODA loop turns into a DA loop. Decide, act, decide, act, decide, act, decide, act, decide, act, decide, act, decide, act. DA, 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 DA. Because most of the time is spent over here in the OO part, as all of us know. Figure out where you are, what the picture looks like, I apply ROE, what am I going to do? What if you could put all of that first part in the machine, and then the machine even picks what weapon or effect you're going to apply? In the Tomcat, when I pressed on the rudder, no matter the speed or the angle of attack, the rudder moved. Sometimes to my detriment. I have one more takeoff than I have landings. Because I did something with the controls that it said, okay. That's the way it was designed. Super Hornet, I get to fly that thing as an old man, and I go, okay, and it says, oh, you don't want rudder here. I'm sorry, you don't want, I move the stick. You don't want aileron here, you want rudder. So even though I took that stick and moved it that way, the machine said, well, you want this. Airplane goes that way. The nasty axe, he decides he wants to roll left at high angle attack, and the machine says, I'll tell you how we're going to get over there. That man-machine team is very powerful. So with that, love to take your questions. Sir.
Thank you, Admiral. John Herber with National Defense Magazine. Now that U-Class has been set aside or redefined, what is your vision for the future of Navy long-range strike?
Okay, 3 parts of the question. So we are very anxious to get unmanned platforms onto the aircraft carrier. The instantiation of what used to be U-Class into a carrier-based unmanned system that will do tanking and ISR is how we get unmanned onto the carrier rapidly and at the least cost. As we look at the future of the carrier air wing, and in fact the unmanned system that fits onto the carrier sometime in the early 20s is what we're looking at, is going to fit into the future air wing. How I put that network together is going to be key. I will tell you that our network is not simply the range of the aircraft, it's the reach of the network. And so our unmanned system is going to participate in the reach of that network when we get to that point. In its ISR mission, it's going to be able to help me build a picture. In its tanking mission, it will be able to free up to 6 strike fighters, Super Hornets, Ts and Fs that currently do the tanking mission. The future of strike warfare actually goes to the future carrier air wing writ large and how we're going to approach that in the future. As to the unmanned system that would participate in long-range strike, that would be a future instantiation of an unmanned system that would capitalize on the learning we do with this first.
Sir, George Nicholson with the Global Special Operations Command Foundation.
About 3 weeks ago at the Atlantic Council, General Miller started his presentation by saying one of his biggest concerns right now is the dependence the Marines have right now on GPS, and that's got to be solved. Interestingly enough, the next day, the Chief Naval Operations said exactly the same thing. Once you briefed on information, having to pass the information, what are you looking at in terms of a degraded GPS environment, a degraded communications environment? And Admiral Richardson said also along the same concerns is that we've sold off bandwidth to commercial sectors now. So as we grow in capability, is the bandwidth going to be there, or what are the alternatives for GPS?
If I go into specifically what we're doing for GPS and comms, it'll get rapidly classified. But I will tell you that the assumption we're making is that GPS, as we currently understand, is not going to be available, and the comm system that we currently use as a foundation is not going to be necessarily available. We are operating, or we are going into an examination of the electromagnetic spectrum, and being able to use agility across the entire spectrum. The frequency pieces that have been sold off are negotiated positions that the commercial world wants to go into because they have that piece of the frequency spectrum has advantages for us, has advantages for the commercial world as well. Our work goes into where outside of those actual pieces of the frequency can we operate with impunity. And so we're investigating how to get precision navigation and timing into our system, how to get relative clock timing to be able to do that, how to create a network that's self-forming that might not rely on a GPS signal up there, but actually relies on a different kind of timing signal. And we're going forward with a lot of those mitigations. Some of our currently programmed mitigations go after exactly being able to protect our current GPS network. But we're also going after how else do we do precision navigation and timing, and then how can we communicate across using that timing from node to node. Whether we do an aerial network or a different place for that network, how you'd be able to talk back and forth to nodes. That requires that we make every platform a node. And so every platform, even if it's not if you're not using that information, participating in its own world, it actually has the capability to pass information as either communication node or a timing node. Sure.
And all the questions, Seaport Magazine. You talked about trying to integrate the air with the sea platforms. Part of the problem we've had is that aircraft can upgrade their electronics a lot faster than the boats can. So there's sometimes a gap between what your airplanes have and how they can communicate with the ships. Are you working? You have to coordinate that with the seaside.
Yes. So I won't get too far into General Chris Owens' world and OPNAV N95 or Pete Vanna's world and OPNAV N96. But we have a very active conversation going on right now, specifically to how F-35B is going to talk to the L ships. So getting Link 16 down to the ship. Previously, the aircraft that operated on the L ship didn't require a Link 16 connection with the platform. Well, now we do. We're trying to digital interoperability in the United States Marine Corps and link all of their platforms. So most importantly, coming off of the L ship is the V-22 and the F-35B. But being able to create the system inside the L ship that upgrades the communication capabilities of that platform, which we didn't have before. We're also examining what kind of information comes off of the airplane. So how do you package all of that potential information that comes off? Every time we take an aircraft carrier into dry dock, and then most importantly, when we take it into reactor complex overhaul, RCOH, we upgrade the weapon system to improve the links between the ship and critical places like Combat Information Center and the Admiral's TSCC with the airplanes that are airborne, whether it's the Hawk link coming from the helicopter into the USW and surface capability, TSC, DSS there inside the carrier, the Zulu module, or whether it's getting the long-range air picture, coming back from the guys that are way out front. Putting that information into decision makers' hands and creating that information on the ship is something that we're after. We're teaming with OPNAV N26 with the networks piece, the integration and interoperability piece. The investments are going that way as well, as are the investments in electromagnetic warfare, non-kinetic operations, in order to get to exactly just what you're talking about. Because we can't fight in the 21st century warfare if we're not connecting the ships in the air. Great question. Yes, sir.
Last question. Make it again.
Thank you, Aaron. I'm Richard Quill. I'm here for BreakingDefense.com today. Where are those three unmanned wingmen for the F-35? What are they going to be, and what program is going to produce them, and do you see them flying with the F-35?
So what I hope to do is, let me break this down for a second. The competition right now in the unmanned world aboard the carrier is for the air system itself. We have already built and installed the common control system, the way in which we control that, and we're modifying the aircraft carrier. That is ongoing as we speak. The actual air system that we have is what's going to be computed. In its ISR role, what I would hope to do is be able to use technology and innovation that when that aircraft in the mid-20s comes off the flight deck doing an ISR and a tanking role, we can connect it through a waveform still to be determined to an F-35 or an E-2 or a Super Hornet and be able to give that aircraft commands. We have only recently, the U.S. Army has demonstrated and the U.S. Naval Test Pilot School has demonstrated air-to-air control of a manned to an unmanned platform. We currently have Fire Scouts and MH-60 Romeos operating off of our patrol combat ships. But currently we don't have the MH-60 Romeo controlling the Fire Scout. It's controlled from the ship through a link. What we hope to get to is that connection. So if you picture that ISR unmanned system that we're talking about right now, as a carrier-based unmanned system that used to be U-class, and we find a way to connect the control system across to a person in a manned airplane, that's where I get that capability. In its capabilities as an ISR platform, if it is sucking up information as we send it out to surveil the battle space using whatever sensor is on it, it's already going to send that information back to the ship. Why could it not send the information into the cockpit of a manned aircraft, whether it's E2 or a tactical aircraft, across the same link that it sends to the ship? Right now, I communicate in link 16. We're doing advanced waveforms like TTNT, Tactical Targeting Network Technology, ways to move big pieces of information. If I can figure out a waveform between that manned airplane and unmanned, that's where I'll get them from.
With those wingmen beyond.
Not current. The thing we currently have, again, ISR and tanking, is I would be able to share the picture that those sensors are looking at. Maybe they're electronic surveillance pictures. So instead of having just my own airplane's apertures on the airplane for sensing the electromagnetic battle space, maybe part of my sensor is that unmanned system that's over there, and it's sending what it's getting from me. The current instantiation, to answer the very first question, to underline the very first question, is the unmanned system going on the carrier here as part of the U-class, what U-class turned into. And we don't have a formal name yet, so I'm not going to, just an unmanned thing, whatever we get to that. That's a tanking and ISR platform. And we will look to learn about future missions in the future. But you can start to postulate on what those unmanned systems could do in the future if we chose to go that way.
Thanks very much, Admiral, for taking the time to give us that wonderful tour de force of the information. It's wonderful to hear somebody inside the building actually talking about innovative thought and giving people the opportunity to make decisions and experiment, if you will. And also to hear someone speak about the JASIS process and 5,000 series regulations as being parachutes producing drag as opposed to help. I think one of the lines I'll remind the group of is that Al-Qaeda and the Islamic State don't have a JASIS process. Anyway, we've got a small token of our appreciation for you. You know about naval aviation. Here's a book about the strategic concepts of Warden and Boyd, air power reform. Thanks very much for being here.